In activity 2 from section 18, we're looking at what happens when things don't easily eliminate. We have to do a little bit of legwork to make it work. So in the model round, we have x plus 2y equals 5, and we have negative 2x plus y equals negative 15. If I just add straight down, nothing's going to cancel. X and negative 2x will not cancel, and neither will 2y and y. So what I have to do is modify at least one of the equations to make it work if I'm choosing to use the elimination method. My choice here in this side over here was to get rid of x. And the easiest thing to do is turn this x into a 2x because I want to make sure that a 2 and a negative 2 will cancel out. So to make that happen, I've got to multiply this top equation every single term by 2. 2 times x is 2x, 2 times 2y is 4y, and 2 times 5 is 10. So they're asking us what happened to the first system over here to arrive at the second system. On this side over here, we have the same starting equations, x plus 2y equals 5 and negative 2x plus y equals negative 15, but we made a different choice. And on this choice, we decided to get rid of the y's. So to do that, I have a couple options, but probably the easiest is to just change one equation, this guy right here. So I got to turn that 2y into a negative 2y. I'm sorry, I've got the 2y here. I've got to turn this y into a negative 2y. So to make that happen, I multiply every single term by negative 2, which gives me a 4x minus 2y equals 30. I line these up, I add straight down, I'll have 5x equals 35, and that will help me solve and get x equals 7. I could take that 7 and plug it into any equation that I see to try and find out what y is. I just went ahead and plugged it into the first one because the numbers are relatively small and easy to work with. 7 plus 2y equals 5. Solving for y, we get negative 1. So the answers are ordered pairs 7, negative 1. And you notice over here on the left-hand side, the one where we eliminated and solved for x, we get the same thing. It really didn't, I'm sorry, we solved for y. It didn't make a difference where we went. We either could do this equation or that equation, solve for x or solve for y, didn't make a difference. Question 2 is the same type of thing, but again, different choices that we have to make. On the left-hand side here, we decided to solve for x, or sorry, eliminate x. So we multiply both the bottom equation by 4. When I multiply the bottom equation by 4, I have 4x minus 12y equals negative 24. I can add my like terms, negative 3y equals negative 15, and solve for y. On this side, we solve for, or eliminate y, so we multiply the bottom equation by 3. 3x minus 9y equals negative 18. So just line these guys up. Negative x, y's cancel, and negative 9. X is 9. We solve it basically the same way. We get the same answer. It's just the order that we're getting the variables in. On the back of this activity, we have the model, or well, we did the model. X plus 7y equals negative 14. Negative 4x minus 14y equals 28. And we're asked to set it up, but don't solve the system. So if you wanted to eliminate x, what would you have to do? Well, we would have to make sure that the x's here canceled out. So if I've got a negative 4x, I think I'm going to leave that because it's fairly easy to turn this 1x into a 4x. Just multiply by 4. So when I multiply by 4, I'm going to have 4x plus 28y equals negative 56. And the second equation, I didn't need to do anything. I left it alone. For eliminate y, I had to make sure that these y's were the same. I've got a 7y and a negative 14. Probably the easiest thing to do then is to multiply this top equation by 2 to turn that into a positive 14y. When I do that, I have 2x plus 14y equals negative 28. And again, we're just setting it up, and we're not solving it in this activity. In question 5, we've got the same basic idea. We're going to eliminate x on the left-hand side, or the middle, I guess, because the equation itself is on the left-hand side. So if I have an x and a 5x, I want to make sure that those are the same number, but different signs so that they'll eliminate. So I multiply the top equation by 5, and it works out really nice, because I'll have 5x plus 20y equals 15. Then on the side for y, if I want to get rid of y, I can multiply this top equation by 5. You'll notice I'm essentially doing the same thing for both of those, eliminating x or eliminating y. By multiplying by 5, kind of cancels everything out. All right. And the rest are the same type of problems. Here we got 5x plus 4y equals negative 14. We'll solve for x by multiplying the second equation by negative 5. And to solve for y, we'll multiply the bottom equation by negative 2. In question number 7, we have 3x minus y equals 2, and x plus 2y equals 3. To eliminate x, I'm going to multiply the second equation by negative 3. To eliminate y, I'm going to multiply the top equation by 2. And then question number 8, to eliminate x, I'm going to multiply the top equation by 2. And to eliminate y, I'm going to multiply either equation. It really doesn't make a difference. By negative 1. I chose the top one because I want to get rid of those negatives if I can. So going ahead and doing this with 1 is not so bad. Where it gets a little bit tricky is in activity 3, where we have two equations that we have to manipulate. We have to turn both of them into something different. So in the model round, we have 4x plus 5y equals 6, and 6x minus 7y equals 38. So if I'm going to make a choice to eliminate x, I want these numbers to cancel out. Now, I have some choices here, and some choices are better than others. One is I could find a least common multiple between 4 and 6. That is an option. The other option is just go ahead and multiply the top equation by this number and multiply the bottom equation by this number, but make sure that one of those is negative. So if I multiply the top equation by 6, I get 24x plus 30y equals 36. Multiply every single term by 6. And then the bottom equation I multiply by negative 4, which gives me negative 24x plus 28y equals negative 152. Now I went ahead and solved this, and to solve this I'm just going to add my terms up. The x's cancel, the y's give me 58y's. This gives me negative 116. Turns out that y is equal to negative 2. I can take that negative 2, plug it in wherever I want to. I don't really want to plug it in over here though, because those numbers are pretty big. I don't want to deal with those. I really don't want to plug it in here either because of that negative. I'm a little scared of that, so I'm going to plug it into the top equation. And I've got 4x plus 5 times negative 2 equals 6. And solve it, and I get x equals 4. In 1b, we're doing the same thing, but instead of solving or eliminating x's, we're eliminating y's. So if we do that, we're going to turn this into a 35 and a negative 35. Multiply the top equation by 7 and the bottom equation by 5. Then when I add these up, I'll end up getting the same thing for x. I'll get 4 for x, and then I can solve that for y. Alright, so again, the key is figuring out exactly what we want to cancel out, making a decision, and then kind of sticking with it. We may have to multiply two equations by something in order for it to work. Like in 2a, we have to do that again. To get rid of that x, one of those has to be a positive 28, and the other one has to be a negative 28. Because I've got two negatives here, it's not really an easy choice. I'm just going to pick one and go with it. I decided to multiply the top equation by negative 4 and the bottom equation by 7. And by doing that, I will cancel the x's out to help me find what y is. And number 3, if I'm going to solve this from scratch, I'm probably going to go ahead with what we did in 3b, and I'm going to get rid of the y's to solve for x, because it just seems to be a little bit easier to work with. If I'm going to get rid of the y's, I'm going to turn these into 14s, because 7 times 2 would give me 14. This one's already negative, this one's already positive, so that's good news for us. Multiply the top equation by 7, multiply the bottom equation by 2. By doing that, the 14y's cancel out, and I'm left with negative 48x equals negative 48. Yeah, the numbers are big, but this is relatively easy to work with because of the fact that these two numbers are effectively the same thing, just one of them is negative. So that gives me x is negative 1. I can take that equation, plug it in wherever I want. I just went with this one because it seemed like the easiest to work with to find out what y is. If we had eliminated x to solve for y, like we did over here, we'd still get the same thing, but the numbers were really big. We'd have 48y equals negative 248. That's a big number. I don't want to deal with that. On the back of that activity, we are solving the system, so we're going to make a choice to eliminate x and eliminate y, and the directions say solve either one, but here's the cool part about this. If we've already set it up to eliminate x, and we've already set it up to eliminate y, we have our answer. We have our x and our y. So on number 4, my decision on eliminating x was to turn this 2 into a negative 10. And to do that, I multiply the entire equation by negative 5. This gives me negative 10x plus 5y equals 15. Add down and I'll have 12y equals 12, so y has to be 1. If my choice was to eliminate for y, or eliminate y, that means solve for x, I'm going to turn this negative y into a negative 7y. Multiply the top equation by not negative 7, because it is already negative, but multiply by positive 7. We'll have 14x minus 7y equals negative 21. Again, add straight down, the y's cancel out, that's what we wanted. We'll have 24x equals negative 24. X is equal to negative 1. So our ordered pair is our x comma y, negative 1 comma 1. So 5, same idea, we have to make a decision. I turn the second equation into negative 15, the top equation into positive 15. Multiply through by 3, multiply through by negative 5 to get this, and then solved it from there. To eliminate y's, turn one of them into a positive 36 and one into a negative 36. Doesn't matter which one. I multiply the top equation by 9 and the bottom equation by negative 4 to get this new equation. This guy over here. And number 6, I chose to eliminate the x's by multiplying the bottom equation by 2. So negative 8x minus 6y equals 6. And to eliminate the y's, I had to multiply the top equation by a positive 3 and the bottom equation by negative 5. And that will cancel out your y's so you can solve for x. Again, you have a choice when you're solving it. I would probably go with the x's to eliminate first because the numbers seem to be pretty reasonable to work with. And 7 and 8, again, same process. Make a decision on what you want to get rid of. Make sure that they will cancel when you add them together. And that's exactly what we have going on in those problems as well. So we have a negative 1 here and a 2 here, so 2, negative 1. And for number 8, we have a 3 and a negative 4 for our solutions.